Welcome, everybody. If you look on Folio, you can see that I posted a new document in the content section that really gets at what is meta-analysis. So a lot of the readings that we're going to do in this course really revolve around reading a recent meta-analysis on a certain topic. And so I really kind of want to just go through, and some of you might know what a meta-analysis is or have conducted one yourself at some point in time. But I think it's a really important mechanism to communicate really important information. So, for example, if you look at the hierarchy of scientific evidence, and some people would probably debate this and say one thing's better than the next. But by and large, I think this pyramid's pretty, it does really highlight, I think, the strongest types of scientific evidence that we have. And at the lower end is these case reports, opinion papers, letters. This might be like a letter to the editor where someone might have some background on a certain topic, but they're not necessarily an expert or someone that's conducted a lot of scientific research on a subject. And so we really want to stay away from those. Those might be good to just to get a general idea of how people are thinking about a certain issue, but it's not certain, it's not something we want to use in scientific or best practices. Animal trials, again, many times we can't experiment with humans, or we don't want to experiment with humans. It would be unethical. We'll go and do some animal trials, and we don't really know often how animal trials will translate to human studies. But again, it can give us some idea of this happens in animal trials. Maybe this is something to consider for human beings, but it still doesn't really rise to a really strong scientific piece of evidence. Cross-sectional studies are pretty common. We'll read a couple of those. That's where you have really a snapshot in time. It's one group of individuals. You give them a survey. You do an interview with them. You do not follow them over time. So it's a cross-section. Again, if you have a pretty representative sample, those cross-sectional studies can give you an idea of what you're trying to look for. It can give you some scientific evidence. But since it's just a snapshot in time, it's not longitudinal, it's not a case control study. It's really just giving you a broad sense of how your sample is representing a certain issue. Case controls get a little bit better. That's where you have not necessarily two representative or a control and an experimental group, but you have two different groups that might resemble themselves in a certain way. So for example, if I want to know how this victimology class is doing compared to another victimology class, we'll say Dr. Dawson's class because she teaches victimology. I can look at that. Maybe I give one certain type of test and she gives one certain type of test, and then we can compare our two classes. Now, we can't assume that those two classes are equivalent, but should be mostly criminal justice students. If they're, the same time of day, say, we wouldn't we wouldn't think that they would be that far different from one another, but still we can't call that a controlled study. Cohort studies are when you follow people over time. So you have one cohort, say 14-year-olds from a certain school, and then you follow them. Let's see how they do when they're 16, when they're 18, when they're 20, and then you start with the second cohort and you follow them. That gives you a pretty good idea of how people progress over time. So it's a pretty strong piece of evidence. And of course, what we kind of call the gold standard, you might see that written down as these randomized controlled trials. That's really where you have a group of individuals and you randomly assign them to either get the treatment or not get the treatment. You would assume that if you randomize people in those two groups, that those groups would be roughly equivalent to one another, they resemble each other, and that any difference in those groups would be due to the intervention or the experiment and not due to something else, because you randomly assign those two groups. It's a very strong piece of evidence. You'll see this abbreviated as RCTs. It's something that gets a lot of funding nowadays because it really does help us isolate effects in two groups. And then actually at the top of this pyramid, you have this thing called meta-analyses and systematic reviews. And really what a meta-analysis is, it's an analysis of many analyses. So the best of those are when people have committed or conducted many randomized control trials, and then you analyze all of those RCTs on a certain topic. You can see these done for things like body-worn cameras. Say, does that reduce violence among police officers in the community. Well, many different people have conducted these randomized controlled trials. A meta-analysis would then bring all of those together to see what the overall influence of body-worn cameras are. So you can kind of get this down here. Meta-analysis, it does come in many different forms. It is a quantitative or a statistical analysis of scientific studies. And they've gotten pretty sophisticated in recent years where they're able to really start to control out the qualities of the study and see if that has an impact on the results, using different types of hierarchical levels. Again, we won't go into much depth there, but I did want to give you a little bit of background on what a meta-analysis is, why it's important for this class, and why I use it quite a bit in terms of getting recent studies on a topic. And so you can dig into these links a little bit more. Again, this is on Folio. But if you have questions about like what is meta-analysis or what is this saying, what's really kind of important, what's kind of cool about this is what's called an effect size. So one study might be conducted and it gives you one effect size, even if it's a randomized controlled trial, and another study is conducted and that gives you a different sort of effect size. Well, which one is right? Which one's correct? Well, they're both probably correct in that certain situation. And so what a meta-analysis can do, well, if there's 10 of these studies done, what's the average among all of those 10 studies? That's your effect size. And that's a real big strength of meta-analyses, is that it can take a lot of different information and give you sort of one overall sense of the impact of whatever it is that you're looking at. And so in this class, as I mentioned, I think that's sort of the best way to communicate some of this information. You don't have to, as you're going through that, know all of the statistics, know the ins and outs of all the quantitative techniques. But if you kind of understand what the output is telling you, what the tables are telling you, that's really what I want you to get out of these articles. So don't get caught up on the statistics. If you're interested in that, I certainly can help you talk through that. Most people don't take me up on that. But certainly, if you have any questions about meta-analyses and the statistics and what goes on kind of behind in the software, I'd be more than happy to kind of elaborate on that a little bit more. So check out the sheet that I have posted in Folio. Watch, hopefully this video is helpful. And if you have any other questions, as always, just let me know.